Good morning, everyone. This is Sirichandra from CSCF, roll number 249518005BN. Today's subject is data structures, and we are going to talk about introduction to data structures. Data structures are specified formats for organizing and storing data efficiency. They enable efficient data. They enable efficient data uh, management and retrieval. Understanding data structures is fundamental to designing efficient algorithms. Next is the importance of data structures. Data structures optimize performance for data processing tasks. They help reduce time and space complexity in competitions. Choosing the right data structure is crucial for software efficiency. Sorting algorithms are core to computer science education and practical programming. Visualizing how algorithms operate makes their behavior initiative helps compare complexity and stability. And aids teaching. Unified framework that supplies consistent visualizations for sorting implementations written in both Python and Java provides a fair, extensible platform for learning, demonstration, and research. This project builds such a framework by decoupling algorithm logic from visualization through a language agnostic event model, offering visualizers in Python and Java and an optional web front. And so algorithms implemented in any language can be replayed and compared identical. Importance of data structures. Data structures optimize performance for data processing tasks. They help reduce time and space complexity in computations. Choosing the right data structure is crucial for software efficiency. Types of data structures. Data structures are broadly classified into linear and non-linear types. Common linear structures include arrays, linked lists, stacks, and queues. Nonlinear structures include tree, graphs, and heaps. This review. The overview of this topic is that the framework includes instrumental implementation of common sorting algorithms like bubble, insertion, selection, merge, quick, heap, and radix. These are all the common sorting algorithms in data structures. A compact language agnostic event protocol that is compare, swap, overwrite, overview, highlight, snapshot, and done. Engaged as JSON. Next is visualizers implemented in Python and Java. Next is optional web UI, that is Canvas or HTML5, that receives events via WebSocket to enable platform independent demos. Next is types of data structures. Data structures are broadly classified into linear and non-linear. In this, linear includes arrays, linked lists, tags, and queues. Non-linear structures include tree, graphs, and heaps. Next is arrays. Arrays are collections of elements sorted in contiguous memory locations. They allow random access to elements using indices. Arrays have a fixed size and can store multiple data types. It creates clean instrumented sorting algorithm implementations in Python and Java that emit standardized events. It designs a minimal extensible JSON that is overview, override, and then call this event schema describing algorithm steps. Implement visualizers in Python and Java that consume the same string and animate operations identically. Support in process, which is a single language, and interprocess, that is IPC or WebSocket mode. So any backend can drive any frontend. It provides UX controls, step, play, pause, and speed, and statistics, comparison, swaps, elapsed time. Document the API and make it easy to add new algorithms and visual styles. Arrays are collections of elements stored in contiguous memory, as we have already read. Next is linked list. Linked list consists of nodes where each node points to the next node. They enable dynamic memory allocation and efficient insertions and deletions. Variants include singly, doubly, and circular linked list. Stacks. Stacks follow the last in and first out, that is LI and LIFO principle, and the other principle is FIFO, which is first in and first out. They are used for function call management and expression evaluation. Operations include push, pop, and pick. In this, it requires Python and Java. And then the methodology is design event model, instrument algorithms, implement visualizers, communicate models, communication modes, controls and metrics, testing and documentation. uh, Next is queues. Queues operate on the first in first out principle. They are useful in scheduling and buffering applications. Variants include simple queues, circular queues, and priority queues. Next is implementation outline and file structure. In this the workflow is it designs JSON event model. Next is it implements instrumented algorithms. It build visualizers. It connects backend to visualizer. Test deterministic replay with identical random seeds. And next is document and package. Next is hash tables. Hash tables store data in key value pairs for first retrieval. They use hash functions to compute the index for data storage. Collisions are handled through techniques like chaining or open addressing. Trees. Trees are hierarchical structures with a root node and child node. Binary trees have at most two children per node. They are essential for searching, sorting, and hierarchical data representation. Next is binary search tree, BST. BST is also means binary search tree, which maintains stored data for efficient search operations. Left child contains nodes with lesser values. Right contains nodes with greater values. Operations include insertion, deletion, and search. The title is Heaps are complete binary trees used for priority queue implementations. They maintain the heap property where parent nodes are ordered with respect to children. Common type includes max heaps and min heaps. Graphs. Graphs consist of nodes which are vertices connected by the edges. They model relationships like social networks or transportation systems. Graphs can be directed or undirected graph and weighted or unweighted graph. Graphs can be directed or indirected, weighted and unweighted. Directed means this graph shows a particular direction, and then unweighted, undirected graph it doesn't show any direction. It is as its wish. And then weighted is the graph has a particular weight for each node to node, from each word to vertices and each edge to edge. That is weighted graph. Where this graph has no weights, it is called unweighted graph. Searching algorithms. Searching algorithms locate data within data structures efficiently. Linear search scans each element sequentially. Binary search divides the search interval for sorted data. Sorting algorithms. Sorting algorithms arrange data in a specific order. Common algorithms include quicksort, merge sort, and bubble sort. Efficient sorting improves data retrieval and processing speed. So these are the types of sorts as we have already read. There are quick sort, merge sort, and bubble sort. So we'll learn about bubble sort. Bubble sort is one of the simplest comparison-based sorting algorithms and is widely used in educational visualizations because of its step-by-step swapping behavior. The algorithm repeatedly compares adjacent elements in the list and swaps them if they are in wrong order. With each full pass, the largest unsorted element bubbles to its correct position at the end of the array. This process continues until no swaps are required, indicating that the list is fully sorted. In the Unified Visualization Framework, bubble sort is implemented in both Python and Java, and each swap or comparison is highlighted visually so that students can clearly observe how the algorithm progresses. The animation shows element comparisons, swaps, and the shrinking unsorted selection after each pass, making bubble sort an ideal sorting point for understanding basic sorting algorithms. This is all about bubble sort. Next, we learn about merge sort. Merge sort is also a kind of sorting techniques. Merge sort is an efficient, stable, and divide and conquer sorting algorithm that recursively splits a list into small sublets, which sorts each sublist and then merges them to produce a final sorted array. The process begins by dividing the input into a list into two halves until each sublist contains only one element, which is inherently sorted. These smaller lists are then merged in a step by step manner, comparing elements from each half and building a new sorted list. In the Unified Visualization Framework, merge sort is implemented in Python and Java with each stage of splitting and merging visually represented. The visualization highlights recursive calls, breaking the list into left and right segments, and merging process where elements are compared and placed in correct order. Next is choosing the right data structure. The choice depends on factors like data size, operations, and performance requirements. Understanding the trade-offs helps optimize application performance. Proper selection can significantly reduce computational complexity. Next is real world applications. Data structures are used in databases, operating systems, and networking. They support features like indexing, memory management, and routing. Efficient data structures improve overall system performance. Conclusions and summary, data structures are essential for efficient data organization and processing. Mastery of various structures enables better algorithm design. Ongoing learning and adaptation are key to leveraging data and structures effectively. Thank you.